2, 1. We're going.
Morning, everyone. Welcome to Spotlight on Clean Careers with F4S and STEM Ambassadors, which we are running today to celebrate several important awareness days, such as International Women in Engineering, Clean Air Month, and more. My name is Neelam, and I'll be hosting the session today, which is Women Engineers in Climate Change. So you're in for a treat. And students, joining us, we'll hear from inspiring role models who have impressive and unique careers, and you'll be learning about how they preserve our planet and protect the environment through the jobs and the work that they do. To the audience, your audio and video is turned off throughout the session, but you are able to ask questions using the Q&A box, so please do get involved. The more you ask, the more you will gain, and we're recording the session. It'll be featured on our YouTube channel and social media channels as well. So sit back and enjoy, and a big welcome. A really big thank you to our guest speakers for volunteering your time this morning. We're really looking forward to hearing all about you. So on the hot seats, we've got Erusa Adizie, Innovation Engineer at Drax Group. We've got Katrina Mcgill, Head of Operations at Desolenator, and Ayanktika Mitra, Business Strategy Director at TISCIS. So over to you. We've got 3 amazing speakers, a great panel, a great lineup. So we're not going to waste any time. We're going to go straight into it. So Erusa, would you mind starting off and sharing your career journey and what it is that you do, and how you protect and preserve the planet and the environment? Thank you.
Hi everyone, I'm Erusa. So I work as an innovation engineer for Drax. So Drax is a renewable energy company, and we own a power station in the northeast of England, and we provide around 6% of the UK's power. So my job involves looking into projects that will reduce the emissions when we produce power. And obviously we know how important that is at the moment. Climate change is on everyone's mind, and we're needing more and more power from the grid with electric vehicles and all that stuff. So we really need to look at the way to decarbonize that industry and get the UK to net zero. So I love my job because I get to research into technologies and systems and look at how they can be deployed. I get to talk to a wide range of people. I get to talk to manufacturers and research groups about things that they're working on. And I really get to find out a lot of detail about these new technologies, and I have to really think critically. I look into the features of these systems, and I have to think about what they do, how they would work, what would be required to make them work. And then also I have to think about the economics of these systems. We need to, they might look cool, but how much would it cost to deploy them? We have to make sure that it makes financial sense. So I get to look into all those aspects, which I really enjoy. I also really need to think about when these systems will be ready. What will it take to get them ready? Are they just at the research stage? Do we need to invest money to get them to the pilot stage, and then think about the long-term requirements of those features and those systems, which I really enjoy. And I've realized that we really need to have new thinking, because we need to think about everything to get us to that net zero target. Something that my company is doing, which is really cool, we're really looking into carbon capture. So we're looking at the CO2 that's produced at the power station and looking at ways that we could remove it or utilize it in some way. And that's one of the projects I'm looking at, taking that CO2 and making it useful somehow. So that's what I really enjoy. And my background is, I think I've been in energy since my whole career. So I have a degree in electrical engineering, and after leaving university, I started working in actually oil and gas. And then I moved to National Grid in electricity transmission, and now I'm working for Drax in power generation. So I think I've got a really unique insight into the UK's energy requirements. So I love energy. Thank you.
Thank you so much, Erusa, for sharing. Did you always know that that's what you wanted to do growing up? Did you always know that you wanted to apply for engineering? You wanted to be an engineer? How did that come about?
So Basically, yes. So I think I've always wanted to be an engineer. So I have, in my family, I have 2 aunts that are engineers who really inspired me. And even from when I was young, I was always practically minded. I was always the one who would help my dad put together like IKEA furniture and all that stuff. So engineering has always been my passion. And then I think I've kind of realized that energy is my passion too.
Amazing. And in terms of, obviously we're celebrating women in engineering today, what is the position at the moment in your company in terms of the gender balance? Can you give us much info on that?
Oh wow, my company right now is the most I don't know, we've got the best gender balance I've ever had. So in my team, we've got an equal number of male and female engineers. So it's actually really good in my company, and we're really focused on getting more engineers into the company as well. So that's really great, and I love working on that as well.
Amazing, thank you. And you also said that you had 2 aunts who were also engineers.
Yeah.
I suppose the reason I ask is role models are really, really important, and that's why we're introducing you guys to the students in schools today, because it's so important that they have that connection. So were they your role models growing up, would you say? Did you kind of aspire to be similar to them?
Yes, exactly. Exactly what you just said. It's so important to see those role models. So my aunts, they told me about their jobs and they just sounded so cool. Like one of my aunts, she's an engineer, she works in the UN, and I just thought, I want to do that.
Brilliant. Thank you so much for sharing. So what we'll do, Erusa, we'll just pause for the moment. If we've got more time, we'll definitely come back to you for more questions. And thank you for sharing. So Ayanktika, we will come to you next. So same questions. What is it that you do? Break it down for the students watching and listening in today, and share your career story as well, please. Thank you.
Hi there. So I'm Ayanktika, Business Strategy Director which is a bit of a mouthful, but that's the title, at a small company called TISCIS. So what does TISCIS do? We develop and manufacture a special type of advanced material, and we work with mainly titanium and aluminiums, but we transform them to make them stronger. So what's special about it? Well, this little tube that you can see on your screen, it's very thin. It weighs about as much as a packet of crisps, but it will carry an African elephant or 2 Indian elephants on top of it. It can take a lot of load, and it is stronger than anything else out there. So it's a lot stronger than steel, but at a fraction of the weight. So why is this important for net zero, and how does that help us get to net zero? Well, if we apply this advanced materials technology to, say, aircraft components, so landing gear on a plane, if we replaced it with steel, which is what's used at the moment, with this material, we would save 2 million tons on the A320, the most popular sort of aircraft fleet, just 2 million tons just from substituting landing gear. So it's a lot of CO2 emissions saved if you just reduce the weight of components. So anything, whether it's aircraft, spacecraft, irrespective of what the transportation mode, or if it's an object and it moves, if you can make it a lot lighter, so we're looking at about up to 70% lighter, you can reduce the amount of fuel it burns. And actually, one of the other things we're looking at is how do we work and develop systems for hydrogen storage, so that you can really just have very green energy being used in transport sectors. So very excited to have this opportunity to speak to you about this. We are a relatively small company. We're about sort of 20 people based in Farnborough, but the really neat thing is that we develop this technology ourselves, and we're one of 2 companies worldwide who can have this incredible technology. And we're very fortunate to get to work with sort of very large companies like Rolls-Royce, Airbus, to actually, and the European and UK space agencies to actually develop this. So in terms of what I do, I guess my job is to broadly plan out the strategy for the business. So it's looking at how do we take this technology, which is very exciting, but actually make it a production technology? So how do we get from where we are, where it's very much the development stage, into putting it into products that are flying, in a couple of years, that, putting it into an aircraft that you will fly on in a couple of years, but that's much more energy efficient and just burns a lot less carbon. So the other side of what I do is also to actually look at digitizing our technology. So manufacturing, there's actually a lot of opportunity in manufacturing to use, math skills and science skills and engineering skills to look at how can you make a process more efficient, how can you digitize it. It's also sort of computing skills, developing computer programs to make the process more efficient. And that not only makes it cheaper, so it can, go into planes quicker, but also it means that it actually uses less energy to produce the components. So we're looking at it from both sides.
Amazing. That sounds absolutely fascinating. So how did you get to where you are today? Can you just tell us a little bit about your educational, your background and your studies and whatnot?
So sort of like Erusa said, I was also sort of very keen on building things. I from a young age, I was very keen on, flat pack furniture, just, pretty much let me at it and then, go build things. So I was always excited about building things. I guess I was very much very into sort of maths and physics and sort of the sciences, more so than probably sort of the social studies. But I didn't really know what I wanted to do. So I was sort of interested in a lot of things, but no idea, which direction to go into. So one of the things that I made use of a lot of is work experience. So I know that so there are a number of places where you can look at work experience. I think Workfinder is one of the programs that F4S works with, and definitely grab work experience opportunities, even if it's a week or a couple of weeks. It'll just give you a flavor of different environments and what that will look like. So for me, I did a bit of work experience in different sectors. I did it at universities in materials. I did it in a different sort of research organization for completely different mathematical sort of modeling. So, and also things like young enterprise. So, how do you build a business? So grab all of these little opportunities where you can with your school to just try out different things. So I did a lot of that. I did a lot of trying different things out. I think in the end, I ended up studying maths at university, which is really exciting. I did sort of maths, further maths, physics and chemistry at A-level. Was pretty much a science geek, but still had no idea what I wanted to do. So whilst at university, I started a manufacturing business, so a small startup. And now there are incredible opportunities to actually start your own business as well. It's actually, pretty enticing and very, there are a lot of resources and there's a lot of support out there to help you do that. And I think there's also the Young Innovators program through Innovate UK. So there are a number of places you can look at to start your own business. So I started my own business and sort of did that for a few years, and then decided to join this larger organization relative to what I was running. And because it's such a cool technology, how do we make it work? How do we actually take the technology and make it fly effectively?
And I'm sure that young people watching are thinking, how did you start your own business at university whilst juggling, full-time education and that? Can you tell the young people watching today a little bit about your business that you started at university?
Yeah, so actually, because initially it was doing a lot of the research into, it's a manufacturing business, so you do need a physical factory. Actually, it doesn't need to cost a whole bunch to start a factory. I think we did it on a few tens of thousands of pounds from savings and from friends and family put together. So it doesn't have to cost a lot. actually what we did was a lot of research at the start on the product. So, you know, what is the product? How do we patent it? How do we patent the technology? And a lot of it was, okay, defining that product and looking at the patent side of it, because you need to be able to protect it. And it was then developing the sort of the tech, because the cool thing of what we were doing is, how do you make individual sort of custom parts, but at a very sort of economic, in an economic way. So it was a lot of programming. So I was more on the tech side of things. So it was, how do you program machines? How do you pull it together? And actually, a lot of it was directly using how do you set up a database? You know, you might do that in IT, and you might think, oh yeah, you know, I've sort of done a bit on, you know, Access and Excel, but actually these are skills that when you come to building a product, you absolutely need, and they're so crucial.
Thank you so much, Ayanktika, for sharing your story. So again, we'll pause for the moment, and we will come back to you with more questions. But that was, you know, fascinating. Really enjoyed that. Thank you. Katrina, last but certainly not least, over to you. Same questions to you. Just tell us a little bit about what you do and how you got to where you are.
Definitely. Good morning, everyone. My name is Katrina McGill. I'm head of operations at Desolenator, and gosh, I really enjoyed two talks. Wow. Maybe I'll start with how I got to where I am. I at school did my GCSEs and had to fit my A-levels, and you know, like Ayanktika, I had no idea what I wanted to do, but thought I was quite good at science and maths, and I kind of enjoyed it, so I picked science and maths for A-levels. And interestingly, on Ayantika's point of work experience, it's also useful to find out what you don't want to do. It's a bit old now, but there's a film called Legally Blonde, which is all about a lawyer, and she was my absolute role model and inspiration, and I really wanted to be a lawyer until I did a week of work experience at a law firm and realised the actual day-to-day of the disaster for me to do. I love to walk around and do stuff with my hands, and sit at the desk for 12 hours a day not suited me, so that was really good. Anyways, got to my A-levels, again, didn't really know what I wanted to do, thought that engineering sounded like the application of physics and maths to the real world, which I think is still a fair way to describe it, and I was more interested in how it applied to the real world than the kind of theoretical elements. So I picked engineering, and I ended up, so I did a course that was general engineering for the first 2 years, and then I specialised for my third and fourth year in a topic called manufacturing engineering, which again, Ayantika's kind of touched on already, about how, you know, how do you make stuff? How do you design stuff so that it can be easily manufactured? And I think not only how do you make stuff lighter and more sustainable from that perspective, but also, you know, how do you design stuff that it's easily to take apart and recycle at the end? You know, if it's a mishmash of 10 different things, you can't then do anything with it and it just goes to landfill. But if you can design it so that it comes apart easily, and thinking about these questions of, if you design something that only needs to last for 2 years, don't make it last 100 years, make it last 2 years, and all those kind of questions. So there's a lot on the sustainability angle that I really enjoyed in my manufacturing degree. So yes, I really enjoyed that. And then I actually did a non-technical job, did a business consulting for 2 years, and then after that I realised I really missed my engineering roots, and found my current role at a startup called Desolenator. So what we're doing at Desolenator is solar powered desalination. So desalination is turning seawater into drinking water. So why would you want to do that? So around the world, water is one of our most abundant, but also one of our most precious resources. But most of it's in our seas and our oceans, and then the rest is mostly in ice caps and icebergs. And then the little bit that's left over is for drinking water, is in the rivers but there's not actually that much of it, and it's getting harder to find it in places that are, some places getting hotter. So places like Middle East and North Africa in particular rely a lot on desalinating water, so taking the seawater and making it drinkable. However, there are two big downsides to this. One of them is the waste product that you produce is a really salty seawater that has lots of chemicals in it, and it's often just put straight back in the ocean, and that can be really damaging to marine life. And then the second problem with the desalination methods that exist currently is the energy requirement. So there's a huge amount of energy that you need to take 1 litre of seawater and take it into, or 3 litres of seawater usually, and 1 litre of drinking water. So at my company, we are trying to design a new technology that does it 100% solar powered. So I'll just take 2 minutes to talk about how it works because it's interesting. So we have designed custom designed solar panels, which are called PVT, which stand for photovoltaic thermal. So you've got your ordinary solar panels that produce electricity, and you've got also another type of solar panels that you find, which are the thermal side. So you run water underneath them, and then the water heats up, and it saves you lots of money on your heating bill. So what my company has done is we've combined the two to make a panel that produces electricity and heats up water at the same time. And then we use those two ingredients, the electricity and the hot water, to then distill the water to create drinking water from seawater. So that's what I do. My role as head of operations is largely coordinating our projects. So we've got 2 projects live. The first one is in Dubai. So part of the good things about working with solar is that you get to travel to some really sunny destinations. So we've got our pilot plant in Dubai, and then we have another project in West Bengal and in the Sundarbans in India. So it's a fishing village that has not good supplies of clean drinking water. So we're going to build one of our plants there as well. And yes, I'll stop there.
Again, it's incredibly fascinating. Thank you so much, Katrina. I'm really curious to see what a typical day looks like for you, because it seems like you do so much. Typical day, do you want to map it out for us? Yeah, so there's kind of two typical days depending on where I am. So there's the office. So if I'm in the office, we also have a small R&D facility. That sounds exciting. We're a startup, so we don't have very much money, so it's more just a room with lots of fun pieces of equipment in it. So I usually, if I'm in the office, it's about I have kind of half the day usually on calls. So I'm either talking to suppliers, so so we're building this plant, so that means we need piping, we need to buy our solar panels and make them, and then we have to make sure they get onto site. And there's a lot of logistics work involved in that. And then there's kind of talking to our engineers who are in the office, and they're often doing tests to support our site work. So they've got a solar panel in the office, and they're looking at things like what happens, can we make it a bit lighter, it works while we've got kind of screws around the outside, so can we have half the number of screws, and will it stay leak tight, and all these kind of questions. So it's a mix between phone calls, calling other companies, partners, suppliers, and discussions with the team when I'm in the office, and then the other half of the time I'll be on site, on our project sites, and then that's
really fun. I love having the mix. So, for example, last time I was there, we steel pipes that have been to carry the water around the plant, and so they've been welded together. So the last thing I did when I was there was I was doing dye penetration testing. So you kind of spray some dye on it, and then you spray some chalky white thing around the outside of the pipes, and you look for if any of the dye seeps through, and then that you can tell if lots of the dye seeps through, then you can tell you've got cracks in your welds, which means that over time the pipes are likely to leak. So I was checking those. So, yeah.
Brilliant. Thank you again, Katrina. So I'd like to ask that question very quickly to Erusa and Ayanktika as well. Erusa, in sort of 60 seconds, if you can, what's a typical day like for you?
Well, so like everyone, I guess, working from home, but so I have a lot of meetings. So I've got a few projects ongoing. So I have meetings with various people who are helping with the project, so externally and internally. So a lot. So with engineering, it's a lot of it is working in a team. So you have like loads of different types of people who help make a project come together. So as I said, I'm talking to manufacturers on their equipment, and if I've got with these projects I'm doing, I'm working on progressing those. And then also I have internal meetings with our people in finance or group marketing, so to talk about the energy financials there that can all come together to make sure that we've got a feasible project.
Perfect, thank you. Ayanktika, how about you? Again, 60 seconds because we're running out of time.
As Erusa said, because engineering involves so many people, you actually get to interact with lots of different types of people. So again, we have a physical workshop here. I am on site, and I have been throughout most of the time because we're a manufacturer. So it's physical, workshop. How do we make things? How do we, and also talking to the designers on actually, do we need to make any tweaks to the components, and sort of bringing the two teams together to sort of discuss it. Also, I spend a lot of my time on, some of it is either programming or designing the architecture for the systems we need to build. And some of it also just because if you do any business strategy side of things, you've got to look at the finances as well. So it's a mix of lots of different things, which for me is really exciting.
Brilliant. And Ayanktika, now that I've got you, final career or life advice or any quotes that you kind of stick by, and then I'll go to the others and then we'll close.
I think one of the things people don't talk about is just, you don't have to be ultra brilliant at something. I wasn't, I really am not, but hard work gets you so far. I think focusing and at school, and this is what I did a lot, I studied quite hard, I worked quite hard, and that hard work really pays off, because it might look like, oh, why am I learning this? It doesn't really make sense. But actually, 5 years down the line, and you're using this, whether it's, sine, tan of an angle, it's really useful stuff. It might not seem like it now, but you will almost certainly, at least for me, I've ended up using almost all of it. So, yeah.
Amazing, thank you. Katrina, how about you? Some final career or life advice you want to share?
Oh, I think, my advice is just apply. When I found my current company, they were only looking for a business development, and I had no idea what it was. But I loved what they were doing so much. I just wanted to be involved. I sent them my CV and applied for the job anyway, and they replied saying, "You're not remotely qualified to do this job, but we quite like your CV, and we'd quite like someone to kind of manage some of the technical side." And that was exactly what I wanted to do anyway. So just, most of the time you might not get something, but just apply. Just send your CV or send them an email, whatever it is. Just go for it, just in case.
Brilliant, thank you. And last but not least, any final advice?
Yeah, so I guess I'll talk to the women out there. So I guess a lot of women think that engineering isn't for them. But I just want to say that engineering totally is for you. And yeah, so same as everyone else, just apply, go for it. Like, you're more capable than you know. So, you know, there's a place for you there. So definitely go for it, because engineering is great. Love it.
Thank you. That was amazing advice from all three. Thank you so much to our guest speakers for joining us today and for sharing your stories. Thank you to everyone who'll be watching this back. The audience, you will be sent a short survey form, so please do complete those, and this will be uploaded onto our YouTube channel. We're also on LinkedIn, Facebook, Instagram. We're everywhere. You can find us there, and we really hope to see everyone again soon. So thank you again for your time, and enjoy the rest of your day. Thanks. Bye.